everybody, it's Mrs. Hofferberth. Let's talk about accuracy and precision today. So first off, some definitions. Precision is how close your measurements are to each other. So if I look at the target below here, a set of precise measurements would all be grouped together. So there's one example of a set of measurements that would be precise. There's another. There's another. So all three of those have the measurements, as I'm using as my example here, but have where the marks are all really close together. Now, precision is not about how close to the right answer you are. That's what accuracy is. So accuracy is how close to the right answer you are. When I look at these three different groupings of measurements, only the one that's in the middle is both accurate and precise. On the other hand, you can have some measurements, or in this instance, some hits on a target that, while not precise, on average are accurate, because accuracy is about how close to the right answer the average value is. So on this other target, if I happen to throw 5 darts, or take 5 measurements, and while none of them is right on the bullseye, on average, the point where they would come together is right what it should be. That would be an accurate measurement, although not precise. So again, here what we're talking about is how close are the measurements together, that's precision, and then how close on average are they to the right answer. And you do have to consider the right answer. You do have to consider the average value when you're deciding whether it's correct or not. So let's look at some numbers like you're going to be doing in lab. So let's say I have some measurements. So here there are 5 different measurements using volume, using milliliters for your unit. So 15.65, 15.88. As I look at all 5 of these measurements, they're really pretty close together. They're all 15. There's a little bit of variation when you get to the hundredths place, or the 10th place and the hundredths place, but in general they're pretty closely grouped together. And the average value is 15.73. So as I look at this, I say, okay, well these are all pretty close to that average value, that 15.73. So these, I'm going to say, are fairly precise. If you want to get a feeling mathematically for is it actually precise, generally we're looking for a difference that's less than about 5% from the average value. So you can compare what is my measurement, what is the actual value supposed to be, or what is the average value of all of those measurements more accurately, and are they within 5% of one another. That, generally speaking, counts as precise. So these are fairly precise. On the other hand, if I look at what the actual value is here, the actual value is 18.33. 15.73 is not close to 18.3. That is not even close to being within 5%. That's a big difference. That's 3 milliliters out of a total of 18. That's about a 12% error. So this is not accurate. So again here, your goal is to say, are the measurements close together? Compared to the average value, are they all very similar to one another? And then for accuracy, are they close to the actual value? And again, the guideline here is within about 5%. If they're within 5%, the world is a happy place. If they're not, maybe it's time to go back to lab and try again. That's accuracy and precision.